So when it says against the wind, you are going to subtract because it's hurting you. It's slowing you down. Then it tells me how long it took. It took 4 hours, so that is my time. It also tells me how far I went, 1,200 nautical miles. All right, that is against. Then we have with the wind. When I'm going with the wind is helping me. So my rate is going to be the rate of the plane added to the rate of the wind. In this situation, they tell me how long I traveled, 2 hours. It tells me how far I traveled, 500. Okay, so the wind helps. So I'll say it. Yeah. So it does say with the wind first and against the wind second. I was saying it right, just writing it wrong. All right, so with the wind is added, against the wind is subtracted. All right. Now, when you have these, you are going to then set them up as equations. Remember, your rate and time are multiplied together, okay? Rate and time are multiplied together. So when you have something like this, you have to group these, all right? You have to group them. Yes? So then when I multiply, that is being multiplied by that entire group, all right? And when I multiply here, that is being multiplied by that entire group, all right? Now, and I will usually do this too, I will give you something that is divisible, just like they did here, okay? So instead of distributing, just go ahead and divide. Go ahead and divide both of them, all right? So I'm going to go ahead and divide this by 4 and this by 4, and I'm going to go ahead and divide this by 2 and this by 2, all right? So that you have straightforward P plus W, 1,200 divided by 4 is 300. P minus W, we have 500 divided by 2 is 250, all right? So I'm going to give you something that is divisible, so you can go ahead and divide that time out, okay? Go ahead and divide that time out. All right, and so it's already set up for an elimination problem, and they always will be, because you're always going to have, the question was, would you have both with the wind or both against the wind? No, you won't have both with the wind, you won't have both with the current. One's going to be going one way with it, one's going to be going against it. So you're always going to have that plus and minus of those variables, so that when you add, it's already set up to cancel, all right? So I can go straight to my addition here, add down, right? The W's will cancel, I have 2P, and then I'm just going to add these, 550. And then I have something easily solved. I'm going to divide both sides by 2. My plane is going how fast? Yeah, 275. And how we were miles per hour. All right. So if my plane was going 275 miles per hour, and when I add them up, they equal 300. How fast was my wind? 25 miles per hour, right? Because I can go back to either of these equations. Right here is fine. P plus W equals 300. I know what P is. 275 plus W equals 300. So when I subtract, I get that the wind is 25. Okay? That the wind is 25. Make sense? So with is going to help you, against is going to hurt you, all right? Just think about when you've been in the ocean and you've been going against the waves, right? You're headed this way, waves are coming this way, it's pushing you, all right? That's what happens with wind, it's what happens with current in a boat. So when you're going with it, it's going to help you. When you're going against, it's going to hurt you, all right? Inequalities. In the last chapter, we learned how to graph inequalities with 2 variables. Remember, when you're graphing inequalities, you graph the line, and then you shade it. And remember, the line can be solid or dashed. Remember, if it's or equal to, it's going to be solid. If it's just greater than or less than, it's going to be dashed, right? And then you determine, are you graphing, is your graph or y value bigger than that line or smaller than that line? And that's how you help determine where to graph, all right? So in the last chapter, we graphed 1 inequality. Remember, this chapter is all about systems of equations, where we had 2 lines, 2 linear equations, or we graphed the intersection, or we eliminated it, or we did substitution to solve, okay? Now we're going to be doing 2 systems of inequalities. So two different inequalities. And honestly, the only thing you can do to solve these is to graph, because it's an entire region of the graph that is your answer, just like it was when you graphed one inequality. So let's look at this first one. It says solve the systems of inequalities, and it gives us two equations for inequalities, or two formulas for inequalities. You will want to put this in slope-intercept form, because that negative in front of the y is going to throw you off as to which way you graph it. So you do want to move your x's over, divide by anything that's in front of your y. So let's look at this first one. We have 3x plus y is greater than 4. So to get this in slope-intercept form, I'm going to move my x over to the other side, which means I'm going to leave that y. It's still greater than, but because I moved it over, we subtracted it, so it actually changes signs when it moves across that inequality. The 4 does not. It is a positive 4. It stays a positive 4, okay? The only thing in front of the y is a 1, so we're done, all right? We're done with that one. Let's look at the next one. For the next one, we have x minus y is less than or equal to 8. Once again, we need to move that x over. We have a negative y, so make sure you write the negative y. It is less than or equal to, because I moved him over, he went from positive. When he went to this side, it's a negative x. The 8 stayed the same, which is a positive 8. The y has a negative in front of it, so we are not done. All right, if it was just a positive 1, we're good, but this is a negative 1 in front of it. You must divide out that negative 1. So I have to divide everything by that negative 1. On the left-hand side, I have the positive y. Because I divided by a negative, what needs to happen right here? Yeah, I need to flip that, all right? It still is or equal to, but it is now greater than. The negative x becomes a positive x. The positive 8 becomes a negative 8. All right? We good? So those are both in slope-intercept form, and now we can graph. So we'll graph this one. Where do I start for this one? Positive 4, right? What is my slope? What is my slope for this one, the blue one? Negative 3 over 1. Remember, when it's a whole number, that's your movement. So we're going to go down 3 and over 1. All right, down 3 and over 1. All right, now, is this line solid or dashed? Dashed. Why is it dashed? Because it's just greater than, right? We don't have that or equal to. Since we don't have that or equal to, we are going to make it dashed. And so we're going to dash this line. All right. Now, then we have to determine how we're going to shade it. The y is greater than. The y is greater than. So I'm going to go right here. My y value was positive 4. Where is your y greater than positive 4 on this line? It's all here. So I'm going to shade this side of the line because that's where my y is greater. All right? And you are going to be shading two of these. So you want to make sure that you leave room for giving your final answer, meaning when you shade lightly here, because you're going to be shading two different ones, and you want your final answer to be where they overlap. And so I'm going to shade in a color, but if you're shading in pencil, do it lightly. Do it lightly so you can tell me exactly where your answer is. Because we now need to graph the second line. We need to graph this one right here. So for this one, where am I going to start? Negative 8. And what is my slope for this one? Yeah, so I'm going up 1 over 1. So it's going to be like this. Is this one solid or dashed? Solid, right? Solid. So this line's going to be solid. All right. And then I'm going to look at, now that I have got my final, when I started it was less than or equal to. But when I finished it, you can see that it's actually greater than or equal to because it flipped. This is why you want it in slope-intercept form for these, because that greater than or less than will determine where you shade. So for this one, I start at negative 8. Where is it bigger than negative 8? Well, it's everything up here. So technically, this shading is everything on this side of the line, all right? So for this guy, I'm shading here. But I now have a system of inequalities, which means the only actual answer is where they overlap. So my answer for this one does not actually include any of this. And you don't have to erase, you just need to darken. It doesn't actually include any of this because none of that overlaps. The only place that's actually included for this particular one is this wedge of a region that is up here. This is my answer for this system of inequalities. So when you're giving me the answer, you want to shade lightly to see where they're going to overlap, but then you want to let me know what your final answer is, okay? So you're welcome to use colored pencils, just like I did. Or you can use a regular pencil, shade lightly, and then make sure your answer is shaded more darker so that I can see, okay, that's their actual answer. Because the only part of this that's the actual answer is that wedge. It did not include those other pieces that just helped us get there. You know, you could check it for graphing by plugging it back in. You can actually check this as well. You can choose any point over here and plug it in. So if I wanted to pick a point, I could pick a point and it will work. It will give me a true statement for both of those. Okay, so if you want to check and make sure you shaded the right region, you can pick any point in the region that you shaded and it should work for both of those original formulas. It should give you a true statement. So when you plug it in, it's going to give you some number over here is going to be bigger than 4 because that's what your statement says. All right, and so you'll get a true statement. All right, let's try one of these. Page 321, number 10. So the first thing I want to talk about is your rules or your steps. Graph your inequalities on the same graph. Find the solution where they intersect. In order to check, you can just pick one of those points and plug it in. There are going to be what's called special cases. Solve the systems of inequalities. So you'll notice that it has x is bigger than 0, y is bigger than 0, and then it has a line, what we're familiar with. Those are actually both lines. Remember, x equals a number. That is a vertical line, right, at that point for x. And y equals a number is the horizontal line, all right? So y equals 0 or x equals 0 is actually going to be an axis, all right? Meaning y is greater than 0 and x is greater than 0 are also going to be an axis. So if I look at this first one, x is greater than 0. To graph that, where is x 0? Well, x is 0 right here. And remember, it is going to be where x is always 0. All right? So x is always 0 on the vertical line there. So that line is actually going to look like this. It's actually going to be the y-axis when it's x equals 0. If it were x equals another number, it would just be a vertical line at that number. In this case, it's this one right here. Now, because its x is greater than 0, I'm not going to look at where my y value goes up and down. I'm going to look at, just like I would for x, where is my x bigger than 0? Well, it's on the right side of this graph. So when I have a vertical line, I'm going to shade on the right or the left, always, okay? Because it's going to be x is greater than some number or x is smaller than some number. So that's going to be all of this right here, a vertical line. Then I have y equals a number, or y is greater than a number, rather. So when I look at this one, I'm going to find where y is 0. Well, y is 0 right here at the same point. But when y equals a number or y is greater than a number, it is going to be the horizontal line at that. So y equals 0, that's actually going to be the x-axis. If it were y equals another number, it's just going to be this horizontal line at that number. And so it's going to be, it's a little crooked, it's going to be just a horizontal line. And so y equals or x equals a number are your special cases, either vertical or horizontal lines. All right, these are just greater than, so I'm dashing those, all right? And now, where is y bigger than that? Well, y gets bigger up and y gets smaller down. So when it's a horizontal line, you're just going to shade either above or below it, in this case, above it. And then we actually have a third line. We're going to do that like we did all the other ones that we just did. So we're going to take that line, we're going to move the x over. Negative y is greater than negative 2x plus 1. We are going to divide everything by negative 1. So we have y. This is going to flip less than positive 2x minus 1. And we're going to graph that line. Negative 1 up to over 1. This is also dashed because it is just less than. And for this one, we are going to say, okay, where is the y value? The y value is here. Where is less than? It's on this side of the line. So this side of the line right here. So I am going to shade on this side of the line. And so now I have to look where all three of them cross over. Well, all three of them cross over right here in this little wedge. Changing my color in this little wedge right here. And so I have this guy that actually stops right here because it has to be above that x to the right of the y and to that side of the line. So we actually did 3, but your special cases are really those vertical lines. Those vertical lines create some special cases, all right? And you can actually have situations where they don't cross at all. You can have situations where they go opposite directions and you have no answer, right? You can have parallel lines that go the same direction, so it's just where they cross. Okay, so you're always looking for the answer as to where they cross. So let's try a vertical line one. You have a y is greater than 4, and then you have a standard slope intercept line. So y is greater than 4 and a standard slope intercept. So go ahead and graph those. So they want us to write this inequality, which means they want us to give us the lines, tell if it's greater than or equal to, less than or equal to. And so we're going to start with this blue line. I always start with my y-intercept. What is that point? So what is my y-intercept for my blue line here? Positive 1, right? Everybody see that? Positive 1. So I know that I'm going to have y. I'm going to have a greater than or equal to. I'm going to have a positive 1. So the next point that I can see that's clearly on a line here is right there. Clearly on a cross. So I'm going to say, how did I go? Well, I went down 1, 2, 3. That's negative 3, right? Over positive 1. Negative 3 over 1 is my slope. So I'm going to say negative 3 over 1 simplified is negative 3. And remember, you have an x, right? Now, did they shade below this y value or above it? Below, so that's less than. Is my line solid or dashed? Solid. Or equal to. So that's how I'm doing this, right? Now let's look at this second one, this red line. This is a special case. This is either a y with a value or an x with a value. Horizontal line, which is it? Y. So this is y. What is my value of y right here? 1, 2, 3, negative 4, right? Did they shade above that or below it? Below. They shaded above it, right? So that's greater than. And did they make it solid or dashed? Solid. Or equal to. And that's my answer. And so when you're given a picture, you're just going to interpret it. You're going to give me the two answers for what it is, all right?